So hello everyone, this is Team Nexabytes. Myself Chayan Shah, along with my teammates Ankit Ojha and Yash Kumar, and here we are presenting our project for CMPE 273 Enterprise Distributed Systems. And our project is NextMeal, a AI-driven platform. So the problem statement that we are currently working for this project is, so in general, finding the perfect restaurant can be overwhelming with too many options and not enough personalization. So even though existing platform often provide generic list, then that don't really cater to individual preferences like food type, location, or ratings. So users usually struggle to book tables easily or even leave a detailed review. So here we are presenting with the solution for this problem, that is NextMeal. So, NextMeal basically solves this problem by providing an intelligent dining platform. It offers personalized restaurant recommendation based on user preferences, detailed restaurant profiles, and an easy-to-use reservation system. Users can filter results by food type, explore reviews, and interact with an AI-powered chatbot for tailored suggestions. And this is built on modern microservices architecture. It ensures reliability, fast performance through caching, and a seamless experience for users and restaurant owners. Now for the architecture diagram, I'll ask my teammate Ankit, Yash to take over.
Thank you, Chen. With respect to our high-level diagram, we first have our front-end web page. It acts like an entry point to the application for the customers, and it requires them to authenticate themselves in order to explore the other features. So the first thing they need to do is to authenticate themselves, like I mentioned, and that is done through user authentication service, which enables user creation and authentication. It utilizes Keycloak for two-factor authentication and single sign-on through Google account features. And this service communicates with users table in the AWS RDS. So once a user is logged in and is on our home page, they'll see all these popular restaurants come up along with the search functionality, and they can go ahead and open any of the restaurant pages too. All of this is enabled by the restaurant service, which fetches data from different data stores. So one such being RDS again for restaurant relevant information and S3 for image data. It also uses Redis-based Elasticsearch for caching requests from frontend to speed up retrieval. Now, once you're on the restaurant pages, you can also go ahead and see reviews by others and as well as add or manage your own reviews. This is facilitated by the reviews service, which fetches data from a NoSQL-based DynamoDB, which contains the reviews data. Uh, Moreover, on the same page, you can also reserve or book a seat or a table at any of your restaurants of choice. So this is done through two services with a queue in the middle. The first service, which is the queue reservation queue service, it is called by the front end, and it simply writes the request to the queue. The queue is configured as a SQS FIFO queue, the reservation FIFO queue you can see here, and it acts as a connector between the two services and maintains order. The second service, which is the handler service, consumes from this queue and handles requests to confirm or cancel reservations appropriately. And it does so by communicating with the reservations table also on the RDS. It also has a special API endpoint where it fetches reservations for the user directly, allowing them to see their existing reservations. And finally, we have AI Assistant Service, which is a main service, and it implements RAG architecture. So in the front end web page, we provide a chatbot which sends a request with the query, and it is handled by this service. It first calls OpenSearch service containing embeddings created from the restaurant data. It looks for the most relevant information from there regarding the query. It then checks the confidence of the context with respect to the query, comparing the threshold. And if it passes that, it finally sends the context from the query to OpenAI's API for textual response generation, which it returns back to the front end. So this is more or less how a distributed system works with all these different services and other components. To speak more about the deployment process, we go back to Chayan.
Thank you, Yash. So now to explain the entire process of how we deployed our microservices to the cluster, let me walk you through the steps that we followed for each of our 6 microservices. So first we containerize each microservices using Docker. We wrote a Docker file for each services, specifying the runtime environment, dependencies, and application code. Then we build the Docker image locally, and after creating the Docker image, we push them to Amazon Elastic Container Registry, that is ECR. Uh, yeah, this. So you can see all the 6 microservices are here in the ECR. Next, once the images were in ECR, we created task definition. You can look here. So we created task definition in ECS. The task definition is like a blueprint for running a container. It includes configuration details like container image, resource allocation, environmental variables, and port mappings. So using this task definition, we create a task in our ECS cluster. This is the cluster, yeah. So using the task definition, so basically the ECS cluster serves as the runtime environment for our containers, and each microservice runs as a separate task. You can see here. And we utilized AWS Fargate for serverless container orchestration, which eliminates the need to manage the underlying infrastructure. Other than these six microservices, we've also used RDS for Postgres database, DynamoDB for NoSQL database, and Elastic Cache for Redis-based caching. Now I would like to ask my teammate Ankit to take over for the demo.
Yeah, hi, my name is Ankit Toja, and I will be sharing my screen. Let me share my screen now. Yeah, so my screen is visible now. So yeah, so today I will be walking you through uh, my application starting from the login process using key clock for secure authentication, and then exploring the key features of the application's UI. So this is the login page powered by key clock. It provides a secure user authentication and supports single sign-on. So users can log in using their credentials or external identity providers like Google. So I will just walk you through the login process here. So I will log in with my credentials. So now, once logged in, Keycloak redirect us to the main page of our application with the user authenticated. So Keycloak also ensures secure session management, user roles, and access controls. So as we are on the home page of our applications, we will explore the key features of our application. So here you can see that there is a search bar. So if you wanted to check all the restaurants with 4 rating, we can just filter it out and just and if you wanted to check the details of any particular restaurant like pizza men's dance, so we will just click on that, and we will see all the details related to that restaurant. So here you can see all the reviews given by the users to this restaurant, and we can see check out the timings. And if we wanted to book our slots for reservation, we can just simply go to this restaurant and choose a date, and just click on the reservation button, and our slot will be booked for that day. Here we can see that we have previous reviews has been given, and if we wanted to give our reviews, we can just simply give here. So we can add review, so our users review will be added. So now we will check out our profile section here. So here you can see a user detail is mentioned, and we can also explore our booked slots for the restaurant. So if you wanted to cancel any slot, so we can just go here and just click on the cancel button. That reservation will be cancelled. So so now we will navigate to our chat page. So this you can see this is a AI assistant. So if you wanted to ask suggestion from our AI assistant for a particular dish, if I ask them to suggest me some pizza places in my location, I will just ask them. So like here you can see our AI assistant has suggested us some good places. So if I want to check out the place, I can just take the restaurant name, and I will search on my page here. So you see like here you are able to see my that restaurant. So we will just explore that restaurant. If we would like to visit that restaurant, we can just simply make the reservation for our time. We can also check out if it is good or not by checking the reviews. So this is what the key features of our applications. And yeah, we have also implemented the sign out button here. So if we click on the sign out button, we can just simply click on that button here. So it will just redirect you to the login page, and a user will be logged out from here. So so if you will try to access the other pages, so you have to log in again to access the home page. Yeah, so thank you. This is all about our application.